Hi, welcome back to HW 2.6. Real quick, some answers from last time from 2.5. Go ahead and back, press pause, screenshot, do your thing, check your work, making sure that you got these right. This is that piece where we rationalize the denominator because the hypotenuse right there, leaving it in its exact form as the square root of 13, no rounding, no rounded decimals, and sine and cosecant, cosine and secant, tangent, cotangent, making sure especially that everything except cosine and secant, those two are the only positive values. Sine, cosecant, tangent, cotangent, all negatives. All right, let's look at today's stuff. Alrighty, so today we are going to take it a step further with our understanding of trig functions around the unit circle. Starting with some sines and quadrants as a quick overview. All right, so starting with sine, we know that the y coordinate is the sine value, which it also relates to then the cosecant value. These are not the same, right? We know that cosecant is the reciprocal of sine, but the main point here is that on the coordinate grid, y, sine, and cosecant all have the same sign, sign with a G. In that, in the first quadrant, right? So this is quadrant 1, 2, 3, 4, as a reminder. So quadrants, right, go in counterclockwise order. And that the value of sine in quadrant 1 is positive. The value of y in quadrant 1 is positive, and the value of cosecant in quadrant 1 is positive. Of course, we know that the y coordinates are also positive in quadrant 2. And then when we get down to quadrants 3 and 4, right here our y values are negative. Nothing too crazy, and we're going to make that extension then to talking about our x values. Our x's, which we know are cosine and related to secant. Right, so when I'm in quadrant 1, for instance, both sine and cosecant are positive. When I'm in quadrant 3, both sine and cosecant are negative. So then, of course, we can have our little axes here. Nothing too crazy for the x values. We already, hopefully, are familiar that the x values are positive in quadrant 1. And as we move to quadrant 2, x's become negative. And in quadrant 3, they're negative. And x's then, once we get back to quadrant 4, positive again. Wonderful. Moving right along, let's talk about tangent. We know that tangent is actually y over x, right? Or sine over cosine. And that is for tangent, and it's reciprocal cotangent. Again, worth noting, I am not saying these three things are the same, right? Tangent and cotangent are different, but their values, whether positive or negative, their polarity is the same around the grid. So here, let's take a look. Really looking at the combination of our first two. As a reminder, since in quadrant 1, we're dealing with y over x, positive divided by a positive gives us a positive. Great. What about though in quadrant 2? Y divided by x, positive divided by a negative, means that in quadrant 2, our tangent values will be negative. Another way to think about this, tangent being y over x, if we think about those triangles, it should feel pretty familiar to slope. So the slope of the line also tells you whether the tangent is positive or in this case, negative, because again, from left to right, this line would have a negative slope. We can also do it this way though. Moving into quadrant 3, we see y is negative and x is negative. So a negative divided by a negative gives us a positive in quadrant 3. And then lastly, in quadrant 4, a negative divided by a positive is a negative. So make sure you've got these down, the signs or polarities of each trig function and coordinate all around the grid in the quadrants. Let's take a look at why this is important and how we use it. Alrighty, here is our example for today. Tangent of theta is 1/2. Sine of theta is less than 0. Translate that to sine of theta is negative. And we want to find the exact values of the 5 other trig functions. Now, if you're up for a challenge, press pause, see if you can do it on your own. If you're not up for a challenge or you're feeling like I'm not quite sure how to approach that, totally fair. So let's check it out. First, we've got to figure out, we don't know the angle. We don't know the exact angle, right? No one's telling us what theta is, and we don't need to find theta. This is not a matter of using inverse tangent to find the angle. This is a matter of how we can find the other values exactly using our brain, understanding the relationships between all of those trig values. First thing though we can figure out is which quadrant is the angle in, right? Which quadrant of the ones we just looked at had tangent as a positive value? It doesn't matter that it's 1/2, we just need to know that it's positive. Which quadrant had tangent as a positive value, but sine as a negative value? I'm going to think back to right here where I erased it. Sine, my y values were negative in quadrants 3 and 4, in the bottom half of the grid. All right, so sine was negative down here, and tangent was positive in quadrants 1 and 3. So that tells me that I'm working in quadrant 3. All right, so we know that our angle is somewhere in quadrant 3, right? So we're somewhere down here. And we also know a little trick. Since we know that the tangent of an angle is equal to y over x, and here we have that equal to 1 over 2, we're gonna let y be 1 and x be 2, kind of, except if y was 1 and x was 2, that would put us in quadrant 1, which isn't gonna work. We know we have to be in quadrant 3. We know the y has to be negative, so here we're gonna let y be -1 and x be -2. Because a negative divided by a negative is still a positive, but I know my y value has to be negative. So let's say we're about there on the unit circle. Sorry, not on the unit circle, not on the unit circle. My y value, again, is -1. Let's pretend my x value is -2, and I'm talking about some angle that gives me that point. Now, hopefully, once we're there, right, I'm back to the problems we've done before. I'm back to having a right triangle where the sides are, whoa, you guys, what is happening today? Where the sides are -2 and -1, and this is the angle in question. And we need to find the other trig values. Well, just like we did in AW 2.5, I needed to use a little Pythagorean theorem right here, 2 squared, 1 squared, to get that my hypotenuse is the square root of 5. Once we have the side length of this right triangle, we are going back to basic trig definitions. SOHCAHTOA for sine, cosine, and tangent that help us quickly figure out each of those values. Sine of my angle is opposite over hypotenuse, -1 over the square root of 5. Cosine of the angle is opposite, just kidding. Cosine is adjacent over hypotenuse, which is going to be -2 over the square root of 5. And the tangent of the angle, we already know it as 1/2, but we can also see opposite over adjacent, that it would be 1/2. Red flag on the radicals in the denominator, so we know we need to rationalize. But before we rationalize, let's go ahead and find out our other values, right? So let's use cosecant here as the reciprocal. So that's just -square root of 5 over 1. Secant of theta would be -square root of 5 over 2. And cotangent of theta 2 over 1, which is just 2. For a last formal step, go ahead and rationalize each of these by multiplying by the square root of 5 in the top and the bottom, which allows us to write this out as negative root 5 over 5 and negative 2 root 5 over 5. Maybe a wonky number, but one I hope you start getting comfortable with because it is exact. All right, so a little bit of an extension from AW 2.5. Let's take a look at your asynchronous problem. Dun, dun, dun. Here we go. So your asynchronous assignment for today, pretty similar. Given tangent of theta is negative 1 over 3, and sine is positive, find the exact values of the other trig functions. As a reminder, you'll need to first decide which quadrant are we in. You'll need to do Pythagorean theorem to find the hypotenuse, and then use your basic definitions to get sine, cosine, tangent. Flip them for the other 3. All right, good luck, everybody. I hope you enjoy the sunny weekend. That's for period 1. Period 4, you know, we got the rain coming, but y'all are going to be great. Let me know if you have any questions. I look forward to seeing your work. Thanks for watching.